All right, here's another one. So now we're trying to prove that two angles are congruent. So I'm thinking, okay, well, let's see if we can prove these triangles are congruent, and hopefully in a way such that W and Z correspond, and then we can say that they're congruent with CPCTC. Okay, so let's start with our given. So we're given that WO, side WO is congruent with side or segment ZO, right? So WO is congruent with ZO, and that's given. Okay, and then we also are given that XO is congruent with YO. So XO with YO. All right, so we have two sides, and so we have the possibility of doing side angle side or side side side, right? Those are two possibilities. Now, and we could potentially find two angles and do angle side angle or angle angle side, but these two, all we need to do is find either one more side or one more angle, right? And remember that SSA is not a triangle theorem or postulate, right? And I always think of it as if you put that backwards, that would spell a bad word, right? And geometry doesn't use foul language; it's very proper. So this one doesn't work. It's not a thing. It's not enough information to prove that triangles are congruent if you have two consecutive sides and another angle. That's not included. All right. Anyway, so let's see. What would it be easier to find? That these two sides are congruent, or that the included angle here is congruent? And I think the second one is easy, right? These two are congruent because vertical pair, right? So angle WOX is congruent with angle ZOY. And the reason why is because vertical angles are congruent. So vertical angles theorem, right? All right, and then now we can say, okay, well, SAS, we know these triangles are congruent. SAS postulate. And so we just need to name the triangle. So triangle, I'll use this here, WOX. And we can see that WO right here is corresponds with OZ, since they're congruent. So they're corresponding parts. So that means, O corresponds with O, so therefore Z corresponds with W, right? So it's going to be Z, triangle ZOY. All right, and so since W corresponds with Z, we can say that angle W is congruent with angle Z because corresponding parts of congruent triangles are congruent. CPCTC. And another one, so given that measure of angle 1 is congruent with measure of angle 2, equal to, not congruent, measure of angle 3 is equal to measure of angle 4, M is the midpoint of JK. All right. So here, if they're asking for M to be the midpoint of JK, that means, we could prove that that JM is congruent with MK. And in order to prove that those two are congruent, we can use CPCTC, right? So we want to prove the triangles are congruent. We can use CPCTC to prove that the segments are congruent, and then that'll lead us to say that, oh yeah, the midpoint, M is the midpoint, right? If JM is congruent to MK. So that's kind of our strategy here. All right, so let's start with our givens. So measure of angle 1 is equal to measure of angle 2. Okay, so measure of angle 1 is congruent to measure of angle 2. And that's given. And we also are given that measure of angle 3 is equal to measure of angle 4. So 3 and 4 are equal. The measures are equal. All right, and so remember with our congruence postulates, we start with two angles, right? So we're thinking maybe angle side angle or angle angle side. So we talked about SSA not being a thing. AAA is also not a congruence postulate or theorem. It is a similarity theorem we'll deal with later. We'll see later on, but it's not a congruence postulate or theorem. Okay, so two triangles that have all the same angles aren't necessarily congruent. All right, so of the two, it looks like the reflexive property is an easy thing to see on this triangle, right? We can see that that LM is congruent to itself, right? So we can say side LM is congruent to side LM. And the reason why is reflexive property. Okay. The other thing I need to do, and I started talking about this before and I got a little sidetracked, is that when we say that the measures are equal, we need to turn that into congruence, right? Because ASA and AAS both say that, two angles in their included side, for example, if they're congruent, then the triangles are congruent, right? And so right now we don't have congruence, we have equality. So we need to turn that into congruence. So angle 1 is congruent to angle 2 because of the definition of congruent angles. Okay, and for the same reason we can say that angle 3 is congruent to angle 4. All right, so now that we have, we use the reflexive property to say that LM is congruent to itself. Now that we have congruent statements for two corresponding angles in each triangle, we can say that the triangles are congruent by angle side angle, two angles in the included side. That's a postulate. And let's name these triangles. So we'll say JLM is congruent with KLM. Okay, so I got those corresponding parts in the right order. So now we're going to say, okay, well, JM must be congruent to MK. So JM must be congruent to MK, right? So I'm basically taking the outer two letters of each, and so those correspond. And so the reason I can say that is CPCTC. All right, and then now that I know that those segments are congruent, that means that M must be the midpoint of JK. And the reason we can say that is definition of midpoint, right?